Hello everyone. So today we will learn about the Terraform Cloud, overview of Sentinel, that is Sentinel policies, then remote backends, how to implement remote backend operations, and what is the air gap environment. So let's start. Terraform is an open source infrastructure as a code tool that allows users to define and provision infrastructure using a declarative configuration language. That is Terraform Cloud is a hosted service by HashiCorp that provides collaboration, infrastructure automation, and other features to enhance Terraform workflows. Terraform Cloud is a collaboration platform for Terraform, an open source infrastructure as code tool by HashiCorp. It provides a web-based interface, version control integration, and a registry for modules. It allows teams to collaborate on infrastructure configuration. So basically, Sentinel is a policy as a code framework developed by HashiCorp. It allows users to define and enforce policies in the Terraform workflow. Sentinel enables fine-grained logic-based policy decisions for your infrastructure. Sentinel policies can be used to ensure compliance, security, and other governance requirements. It's often used in conjunction with Terraform Enterprise and Cloud to manage and enforce policies across infrastructure provisioning. So in this tutorial, we will use Sentinel policies. We will create the Sentinel policies. Then we will attach these policies to the policy sets, and we will create the workspace, and within it we will apply the run and see what the Terraform policies will do. So basically, if you use the policies with this, it is like a check for the Terraform plan which you are going to run. So let's go. Within my GitHub repo, I have created the Sentinel policy repo. In this, I have created the file ec2.tf and the Sentinel policy.tf. So let's go to Terraform Cloud. Here, I will create the new workspace. I'm going with the default project. And here, we will create the VCS workflow for the workspace. I have selected the go for the GitHub Enterprise. We will go with the GitHub app. So let's proceed again. Here we will click on workspace and then version control and GitHub. And now, okay, so my repo is displayed over here. And here we have created the Sentinel policy. To click on that policy, click on that GitHub repo, sorry. So here our workspace is connected with the Sentinel policy repo. And let's click on create. Okay, now our workspace is ready. Let's go to settings. And as you know, we have only one free policy sets and policy. So we have to upgrade to the paid plan, that is trial one. Now I am going with the basic one. So in settings, you have to go to policy sets. And in policy set, we will create on, click on the connect a new policy set. And no VCS connection. Repository will be GitHub only. We will click on no VCS connection. Here we will give the policy name as Sentinel demo, and we will apply this for the specific policy. So project is default and the policy name is Sentinel policy. Okay, so let's click on the connect policy set. Okay, so error is displayed that name is invalid. Okay, so I guess Sentinel demo. This will be name. Let's see if it's still going to show us error. Okay, so policy set is saved. Now we will go to policy, and here we will click on create a new policy. We will name this policy as Sentinel. And here we will select hard mandatory. That means on the failure of the run, the plan will not execute. So here we will copy the TF plan. This is Sentinel policy TF plan. So I will copy this. And we'll paste it here. Okay. And here policy set, we have created Sentinel demo. Let's attach this policy set to created policy. Now let's go and click on create policy. So now our policy is created and it is attached to the policy set. Now let's go to Terraform Cloud. As our policy is attached, let's go to the workspace. Click on our Sentinel policy workspace. And here we will click on the configure variables. So we will add the variables. Here we will give the name. You can copy this from the official document. Let's copy the value. And click on add variable. And let's add same for the access key, secret access key. Let's copy the value. And we will click on the sensitive. Now let's click on add variables. So now our variables are sets for the Sentinel policy workspace. So now let's click on new run and we will start the run. So here you can see the error is shown. It is because we have not added any tag to our plan. So let's go to GitHub repo, and here in EC2 we will add the tag. So let's copy from the official document. And we will paste it here. Okay, I forgot to click on the edit button. That's why it's not taking the paste option. Okay, so now let's commit the changes. Okay, so again go to our workspace. Let's click on the start run again. So now in this way, we have created the Sentinel policy and applied the plan. Now let's go further to the remote backends. Remote backends in Terraform refer to storing the Terraform state file in a remote location rather than locally. This is crucial for collaboration and avoiding conflicts in a team environment. Examples of remote backends include Amazon S3, Azure Blob Storage, HashiCorp Console, and Terraform Cloud. So in today's session, we will using the remote backends with the Terraform Cloud. For implementing the Terraform backend operations, we will need the Terraform cloud. Then we will create the new organization in that new workspace. Then we will configure the workspace using the CLI driven workflow. So let's go to the to our Terraform. I have Terraform cloud. I have login over here and I will create the new workspace, which is CLI driven. I will provide the name over here demo. We'll go with the default project and we'll click on create. Okay, so workspace is created now. We will copy this syntax as our organization name is demo -1 and workspace name is demo. So let's copy this and I have created a new folder in version control, sorry, in Visual Studio Code. And here I will paste my CLI driven code in the remote backend.tf file. Okay, so let's save this. And with this, I have created one more file, im.tf. Here I have paste the syntax of region access key secret key and the resource in which we have going to create the AWS instance, that is example. Okay, so let's save this also. Now, after setting this all, we will click on the terminal, new terminal. And here we will log into our Terraform cloud. So let's hit enter. So this will ask us to generate the API token. Give the value yes. And the token browser will open. So for now, I will select it for 1 hour. Click on generate token. And we have to copy this token ID and go to our terminal and paste it over here. And you cannot see the token ID. You just have to paste and then enter. So with this, you can see that you are logged in Terraform Cloud. Now we will give the command Terraform initialize. Okay, now we will use the command Terraform plan. Let's wait. So here you can see that this running plan is in Terraform Cloud and output will stream here. So to view what the plan is going to run, we will see this link which is provided in plan. Let's open it. So just see the ID over here. And you can see the plan is running. It is not in the run state. It's just plan. So let's go to our CLI, that is Visual Studio Code terminal. And here you can see the AWS instance name example is going to create. Now let's give the command Terraform apply with auto approve. So here you can see running plan apply is in Terraform Cloud. You can see just the stream will be seen over here. So to view the run, we will again click on the link. Let's open it. And now you can see the same ID is over here. And now you can see the plan is applied. You can view the plan. Let's wait till the plan get executed. The instance is still creating. We have to wait. Okay. So the instance is created now. Let's see in our run. Apply is finished. So you can see the message is displayed over here. In this way, we have created the EC2 instance using the remote backend.tf configuration. With this, our TF state file is secure, so no one can, the team member, cannot change the TF state file, and it is stored remotely. So let's apply the Terraform destroy with auto approve. So this will delete our EC2 instance. You can see for each plan, they are providing the link to open it in Terraform Cloud Workspace. Let's wait. So one to destroy message is displayed. That means the EC2 instance is deleted now. Now we have seen the Sentinel policies, then remote backend, and now we will go to the air gap environment. So air gap environment is one that is isolated from external networks, including the internet. In such environments, traditional methods of fetching dependencies and updates may not be possible. For Terraform, this means you need to plan and manage your infrastructure in a way that doesn't rely on external resources. You might need to manually provide dependencies and manage states files securely. This could involve creating a local mirror of necessary modules and providers. An air gap environment refers to a secure network or system that is physically isolated from external networks. This isolation is designed to enhance security by preventing unauthorized access, data exploitation, or potential cyber threats. In such way, environments, there is no direct or indirect connection to external networks, making it difficult for information to leak in or out. So isolation is basically physical separation. Air gap systems are physically disconnected from external networks, preventing data transmission through traditional network connection. Logically separation means that there is often a logical separation to ensure that even if physical security is breached, the systems remain protected. Security measures. Strict access controls. Access to air gap system is highly restricted and only authorized personnel are allowed to interact with the isolated environment. Controlled data movement. Data transferred into or out of the air gap environment is carefully controlled using secure methods such as manual transfers, removable media, or dedicated communications channels. No internet connectivity. No external network access. Air gap systems have no direct connection to the internet, preventing potential cyber threats and unauthorized access. So this is used for in scenarios where the highest level of security assurance is required. This includes government systems, critical infrastructure, and sensitive corporate networks. So in military systems, in critical infrastructures like power plants, nuclear facilities, and the other critical infrastructure may use these air gap systems. This air gap environment significantly reduces the risk of data exploration since there is no direct network connections of attackers to exploit. So in this way, we have seen Sentinel policies, remote backends, how to implement remote backend operations, and then the air gap environments. Thank you.